chemistry study guide on moles and atoms. And, let's just get out of these instructions and get started right away. So, moles. Moles is, by the long and confusing definition, a unit of measurement that is the amount of a pure substance containing the same number of chemical units. What that boils down to is that a mole is an amount of a substance that contains this amount of those chemical units, which are atoms in this case. So 6.22 times 10 to the 23rd power of atoms is 1 mole. This applies to every element, even molecules. So anywhere where there is, let's say, 1 mole of, let's say, 2 elements. 1 mole of uranium. Whoops. My bad there. Uranium and 1 mole of helium. Both have the same amount of atoms, which is 6.022 times 10 to the 23rd power of atoms. But now we have to write that down every time? Nope. You can just put down Na atoms for a quick little thing. So just Avogadro's number of atoms, which is just called the Avogadro's number. So in both of these, I have the same number of atoms of Na atoms. But I'd be asking, do these both, when you convert the moles to grams, is it going to be the same amount of grams for uranium and helium? Well, nope. This is where we get into the periodic table. So here, the periodic table, let me get out my highlighter for this. You will see this little part under the name. Let's look at helium, and where's uranium down here? Here, 238. That is how many grams of that substance it takes to contain Na atoms. So pick any element on the periodic table. Got indium, vanadium. They will all have this different number under them, this molar mass. So, and it is pretty simple. So let's look at hydrogen. Whoopsie daisy. So you can hang with this whiteboard. 1 mole of hydrogen is going to have 1.01 grams of hydrogen. And then let's say you want to look at beryllium, you just go 1 mole of beryllium, that equals 2. Let's look again, 9.012. But of course you have to put this in conversion format, which we're going to get to right away. Might actually get kind of hard. So molar conversions. This can be a bit confusing, but I'm going to try and make it simple. So let's say I have 0.5 moles of copper, Cu. So you set up a little conversion format. As goes, you bring it down to the bottom. So you put here 1 moles of copper. And as I put previously, you consult the periodic table. So you go down to copper down here, and you see it as 63.546. So you just write that down, 63.456 grams of copper. Excuse my bad handwriting again. So, and as you remember, with these conversions, if it's on top, you multiply. So get out your calculator. I have mine right here. So, and you would just take 0.5 moles and multiply it by 63.456. Boom. So, and what I got, and you should probably also get, is 31.728 grams of copper. Don't forget the units. And of course, at the end of this, you're going to have to convert it to the appropriate number of significant figures, which is, here it's just one significant figure. So that would mean you'd have to go about 30 grams of copper. Look at another problem, this time from moles to atoms. Let's really, this can be anything on the tellurium, Te, because this one's just kind of simple. So, and again, you do the same thing here. You take your moles, you bring them down here, of Te. And what you do here is, 1 mole of Te is, as you remember, it's Na atoms. So what you're doing pretty much is taking that and you're dividing Avogadro's number by, no, you're multiplying it by 0.5. So as you do this in your calculator, you should put parentheses around Avogadro's number to make sure it doesn't mess up your scientific calculator. If you do not do this, you might get the wrong answer, or it just flat out might not work. So let me put this in, 6.22 times 10 to the 24th power. Kaboom, I got it. Then times 0.5. Should spit out the appropriate answer in scientific notation already, but if it doesn't, you're going to have to convert that into scientific notation. Times 10 to the 23rd power of atoms tellurium. There we go. That's how you do a conversion of moles. Alright, let's say that you want to know how many grams of H2O contain Na atoms. So this is where compound molar mass comes in. So, and how would you calculate this if there's multiple different elements? It's pretty simple actually. You just go on down to the periodic table again, our old pal, and you just look at hydrogen and oxygen. Oxygen has 15.9999 of molar mass, and hydrogen has 1.0008. I'm going to round those all up, by the way. So what you would do is you would just add their molar masses. So there's 2 hydrogens, which means that 1.01 times 2 plus 16.00 grams. Let me put also a little thing for grams here. So how much would that be? So we can pretty easily count this out with 2.02 plus 16, which would result in 18.02. You don't just put grams here, you put grams per mole of H2O. And this goes for any compound really. Let's say you want to find CO2 or C6H12O6 or any other compound. It works for all of them, this exact same method. So, and at the end you just add them all up and then represent it with grams per mole. Because where there are moles, there are conversions. So let me just pull out an example conversion for you here, for my trusty little notebook. So let's say we have, this is going to be a hard one, but just as an example, 17.9 grams of C6H12O6, which is glucose. So 17.9 grams of this substance. And we want to convert it to moles, let's say. So what we do here is we take that and we do the same method that we saw for water. So let's go against the periodic table. Carbon is 12.01, so let's round that up. So it would be 6 times 12.01 plus H12. Let's go back again. 1.008. So it would be 12 times 1.01. And then again, oxygen. Let's go back down here again. 15.99999. So that would be 16.00 plus 6 times 16.00. And let's see what comes out of this. So let's turn on my calculator, and 6 times 12.01 is 72.06. Then that plus 12 times 1.01, 84.18, and then that again plus 16 times 6. And in the end, you will get 180.18 grams per mole. So let's go back to our conversion here, and this is grams, so we're just gonna bring those grams down. 180.18 grams. I've got to write down the whole formula again, and that is in just 1 mole. So then we, again, it's the grams are on the bottom, which means you have to divide. So what we would have is 17.9 divided by 180.18, which would equal to, oh wow, let me erase this little part so I can make it shorter, which would equal, for my calculator, 1.0993 grams of glucose, which, let's round that up for significant figures. It'll be 3 significant figures because we have, 1, 2, 3. So let's round that out. So we have, this one doesn't count as significant, so we have 1, 2, 3. So what we have here is 0.099 moles of C6H12O6. And that is how you do these problems. Let's go back to the atoms for a bit. So what I'm going to draw here is called a nuclide symbol. So this X is supposed to represent any element you want. So let's see what all of these mean. So we have A here, C here, and these all represent different things. Plus or minus here. So let's look. So X is the element. Here you put the symbol for the element. The symbol could be something like H for hydrogen, Fe for iron, something like that. A is the mass number. So let's say that we have copper. Copper's mass number is 58.933. No, that's cobalt. Wait, whoops. 63.546. Five, 4, 6 is our mass number. Then down here Z, that'll be its atomic number. Let's look again at copper. 29. 29 is its atomic number. So look at that, you could put it down here. Now here, the plus or minus is whether it's an ion or not. So how you do these ion things is you put how many electrons it's losing. So let's say losing or gaining, actually. So let's say I have 2. It could either have 2 positive, which means it lost 2 electrons, or it could be 2 negative, which means it gains them. So that's the notation for ions. Is here in the corner, it's just going to be let's say this is just a 1 plus a positive copper ion, which this one shouldn't really be here. You can just put a plus or minus if it's a 1, which is a bad on my part. That's the study guide from here on out. Thank you for watching this, and I hope it helps you on your test tomorrow. Thank you.